Hello guys, welcome to my channel, and in this video you will learn how to make sampling distribution of sample means. So taking census of the entire population for researchers is quite impractical. That's why they only use sample from this population and calculate its statistics. Now this statistics estimates the population parameters. So you may do this sampling and apply it in your subjects just like for practical research 1. If you would like to know the average daily allowance of all grade 11 students, or if you would like to know the average height of your classmates from your section, you may do so. Now, the question is, how do we make sampling distribution of sample means? Now, let's take this example. Example number 1, a population consists of the numbers 2, 4, 9, 10, and 5. Let us list all possible samples of size 3 from this population and compute the mean of each sample. So, as you can see in our example here, we have 2, 4, 9, 10, and 5. So, the population consists of 5 numbers. So, our n is equal to 5. And our size, our sampling size is only 3. So, small letter n is 3. Well, you can just list down by yourself all those sampling size of 3 from this 5, but the easiest way for us to know the complete number of sampling size of 3 is for us to use the combination. So using our calculator, we can use combination of 5 taken 3. You may have a different interface depending on the brand of calculator that you're using, but you should have this one. And the answer is 10. What does 10 mean? That means to say we can create 10 sample of size 3 from this population. Now, let's list them. So, the first one is we can have 2, 4, 9, 2, 4, 10, 2, 4, 5, 2, 9, 10. Let me scroll down. After 2, 9, 10, we can have 2, 9, 5, 2, 10, 5, 4, 9, 10, 4, 9, 5, 4, 10, 5, and 9, 10, 5. So that is the 10 samples of size 3 using a combination of 5 taken 3. Now, after taking and listing all the samples of size 3, now let's take their corresponding mean. So in order for us to get the mean, just like for this one, we can have 2 plus 4 plus 9 all over 3. That's equal to 15 over 3, which is 5 or 5.00. So we can have 5.00 here. Here it's 5.33. It's 3.67 on the third one. 7, 5.33, 5.67, 7.67, 6, 6.33, and 8. So we just made the first two steps on how to make the sampling distribution of sample means. First, list down all the samples using the formula combination of capital letter N taken small letter n, where capital N is the population and small letter n is the sample. So here is the table that we made a while ago. And we are going to list down all these samples, all sample mean just once, like this, and write their frequency. So in this case, only 5.33 appeared twice and the rest appeared once. And the total should be 10, which is our combination value. Now, after taking the frequency, we should write the corresponding probabilities. So the probability value P of X bar, or the sample probability, is the frequency divided by N. So that's 1 over 10 for all except this third one, which is 2 over 10. And the total should be at 10 over 10 or equal to 1. And here it is. So let's have a recap. We're going to list down the sample mean and we're going to write its frequency. After that, we will be writing the corresponding probability values and make sure that the total is equal to 1. So that's it. That's how we make and how we complete a sampling distribution of sample means, specifically for this example with a population of 5 and a sample size of 3. If you are requested to make the histogram, this is how the histogram looks like. So on the horizontal axis, you can see the sample means, and the vertical axis contains the probability values. And we can just project a very slight normal distribution here. Let's have another example. Samples of 3 cards are drawn at random from a population of 8 cards numbered 1 to 8. So our population n is equal to 8 and our small letter n, which is the sample size, is equal to 3. If we're going to use the formula, that should be a combination of capital letter N taken n that's equal to combination of 8 taken 3, and using our calculator, combination of 8 taken 3, that's 56. That's a lot. So that means to say you are going to list down 56 combination of 3 numbers from 8 cards with numbers 1 to 8. So we're going to skip that part because it will take a lot of time for us to list down that 56, but this is a summary. So after listing down that 56 sample size of 3, you will get this sample mean and the frequency for each and the corresponding probability. Now if you will look at its histogram, this is quite a perfect normal distribution. By the way, if we're going to go back with our example number 1 for the sample mean, these are means from different samples of size 3. But let's take a look on the population mean. We have the population of 2, 4, 9, 10, and 5. If we're going to add them, that's 2 plus 4 plus 9 plus 10 plus 5 and divided by 5, the population mean is equal to 6. And here are different sample means. So the difference between the sample mean and the population mean is what we call the sampling error. So look at this one. The corresponding sample of this sample mean we could say is a perfect representation of the population because they do have the same sample. Unlike this one, with a sample mean of 3.67, its sample mean is far from the true population mean. So the differences of the sample means from the population mean is what we call the sampling error. So let's have a recap of how to construct sampling distribution of sample means. So number one, determine the number of possible samples that can be drawn from population using the formula combination of capital letter N taken small letter n, where capital letter N is the size of the population, small letter n is the size of the sample. Next, list all possible samples and compute the mean of each sample, and construct a frequency distribution of the sample means obtained in step 2. So I hope you learned something from this video. I'll be meeting you using the Google Classroom this week. Bye.